Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem in the list is flip equivalent binary trees. Let's visit the problem on LeetCode. So for a binary tree T, we can define a flip operation as follows. Choose any node and swap left and right child subtrees. That's it, entire subtrees. Not just the values or not just the nodes, entire subtrees. Flip them. Now, a binary tree X is flip equivalent to binary tree Y if and only if we can make X equal to Y after some number of flip operation, and those numbers are not given, or we don't have to only in that number of operation you could do it, which is just like flip entire subtrees as many times as you can. But then at the end of the day, they need to become equivalent to each other. That means they are flip equivalent binary trees. So given root 1 and root 2, we just need to return true if they are flip equivalent, otherwise false. So basically, it's just checking two things. First, imagine in order to see if two trees are equivalent or could be converted to equivalent trees is when their root value is same, right? Root value is same, or their left subtree is equal to their right subtree, or left to left, and right to right, or left to right and right to left. All right, simple. So if you see over here, what I meant is they will be flip equivalent if the root, see, you cannot flip root has to be equal. So these are equal, but then left can either be equal to their left, and when I'm saying I'm not saying just left subtree. And it will happen for all the nodes, okay? It's not just this node. I'm just saying this node at a time, one node at a time. That's what I'm trying to say. But here, this is not equal. So what we can do is we have to check either left to left or left to right. So now we see this is equal to right. But here, since this is equal, then left has to be equal to other one's left, otherwise we will return false, okay? Then here as well, these two have to be compared, and there its left has to be equal to either left or right, which is basically right matching. Left is matching with right, and same can apply to all the other nodes. So honestly, this is really simple. So this becomes equal to over here, and and this become equal to the right of this, and they have, in this example, they have done pretty good job of flipping all of it at every node they have flipped, and we can see. All right, so let's just write our solution. It's quite simple, DFS simple, and just checking if their one tree is either equal to the left, the root need to be equal, and let's check root values, and then check either left to left of this current root, like root 1's left to root 2's left, root 1's right to root 2's right, or this is like and, or root 1's left to root 2's right, root 1's right to root 2's left. Simple. So let me switch the view over here. Let me switch the view. All right, so what I said is, first we can check if not root 1 and not root 2, that means what? They are equal, so we return true. But then if not root 1 or not root 2, that means we return false. Like if we have root 1 and root 2 doesn't exist, or root 2 is none and root 1 exists, that means they can never be equivalent, because root cannot be flipped. And here one more thing we can do is, if the values are not same, that then also we can basically or let's just keep it separately. Or you know what, yeah, I don't want to check it when the values are none and I am trying to check it. Okay, but let's have not, although like we will short circuit, but anyway, if root 1 dot val is not equal to root 2 dot val, then we also return false. Otherwise we return self dot flip equivalent on root 1 dot left and root 2 dot left, and this has to be equal to, these must be equal, and right also must be equal. All right, we're checking all of it, not just left side and right side. This together or we check left to right and right to left. So this will be left to root 2 is right, and so, and I think we can do over here, we can just go inside, and root 1's right to root 2's left. Yes, that's pretty solid. All right, I think you guys can see it. Let me zoom out if you can't. All right, so let's try to run our answer. Passes the test cases. Let's submit. All right, so let's write the time complexity. Which is big of n, and that's because best case or worst case whatsoever, we're going, in this case we can call it best case. That means we're comparing all n nodes to the other trees n nodes, and we're traversing both nodes together. All right, so don't think why, like, you know, it's big of n because there are two nodes. See, we are traversing both of them together, and it's visiting left of each node together, or left or right node together. Like, we are pairing them up, but we are visiting, if there are n nodes in one of the tree, then we're visiting n nodes together, right? And space complexity is going to be big of h or n, you can say it, worst case, when it's just one linear tree. That's not tree anymore, it's like linked list. Whatsoever. All right, let's go back to AlgoYogi and mark our problem solved, and ta-da. See you guys in next problem. Until then, bye bye. Chada.